Okay, so 6.4, which begins on page 330, one theorem called the triangle midsegment theorem. However, this theorem is what we call a strong theorem because you get one thing that's true, you get two things out of it. If you can establish that you have a midsegment, you get two conclusions out of it. A very strong theorem, and it's got a lot of implications, none of which is very hard. Now, the first page and a half of this is the author trying to get you to prove it. We are not going to prove it. It's one of those things that's fairly intuitive. I think you'll accept it without proof because it makes good sense. So I'm just going to tell you what the theorem is, and then we're going to go play with them a little bit, and then we'll be done. It won't take very long for this lecture because it's not a very hard theorem. It's just a strong one. It's just not very hard. Take any triangle at all. Find the middle of two of its sides. So I have a point right there. And I'm saying that that's equal to that. Find the middle of this side over here. And I'm saying this is equal to this. So you found the midpoint of just two of its sides. And you connect them. That's not a really great picture, but we're going to go with it. As soon as you connect them, this thing right here is, the name of it is midsegment. And I think that's fairly obvious why we call it that. A midsegment connects the midpoints of two of the three sides of a triangle. And two things come from this. As soon as you've got one of these, you're guaranteed that, things on here so I can refer to it. It's guaranteed that DE will be parallel to AC. So in other words, if you connect the midpoints of two sides, that segment will be parallel to the third side. And half its length. Half of AC is equal to DE. This will be exactly half of the line that it's opposite of, or that it's parallel to. Whatever length this has, this will be half. A better way to write that for algebra purposes is, so that we can dodge this fraction bullet, is to write, it's the same statement, is to write that AC is equal to twice DE. This is easier to use algebraically because it's a lot easier to distribute a 2 than a 1/2. But they say the same thing. It's a 2-to-1 relationship. The longer one is equal to twice the little one. Or half the long one is equal to the little one. Either way, it's the same statement. This is easier to use for algebra. This is the way they state it in the theorem, but this is a lot easier to use for doing algebra problems. Okay, so we get this. And we get this. If this is x, then this is 2x. Okay, that's the theorem. Now you've got it, and they spend a page and a half, like I said, proving it. I don't think that's necessary. It's more important that you be able to apply it to different situations. So, one other thing. And I got too much junk going on there. I want you to know that there are 3 midsegments per triangle. This one I showed you. If these are midpoints, then this is a midsegment. But if I find the middle of this side, then this is a midsegment. And it is parallel to this side and half its length. Yeah? And I already have the 2 midpoints here. If I connect them, this is parallel to this and half its length. And what's really, really cool about all this is when you draw all 3 of them, you get 1, 2, 3, 4 triangles, and they're all equal to each other. They're all congruent. It's kind of a cool thing. I'm trying to decide if I want to prove it to you or not. But these all have, this has a triple and a single, this has a triple and a double, which means this is the single. And that makes, well, yeah, this makes good sense. I don't have to prove it to you. Remember, this is half the length of this. Well, if this is 2 of those marks, then this is one of them, right? Same length as each of these pieces. This one right here, if it's half of this, is a triple mark because it's this long, half of it. And this one right here, which is parallel to that one, there's 2 double marks there. There's this double mark there because it's one of those double marks, and you get every one of those triangles equal side to side. Something to know. Okay. Look at example. Example 2 wants you to prove it. So look at example 3. This is an application of it with a roof truss. It says triangles are used for strength in roof trusses. In the diagram, now you look at, see if you can find these segments as I read them. You look at the picture. In the diagram, UV and WV are mid-segments. UV and WV are mid-segments of the big black triangle on the right. Are you seeing it?
Mm-hmm.
Find UV and RS. What would UV be? No, UV. 45, because it's half a 9, the side that it's parallel to, right? 45. And the other one we're supposed to find is the length of RS. How long would RS be? 114, because now we got to double that one to get the long one. So we got 1.5, and we double the other one to get to what we're, based on this film. It's pretty easy, right? Okay. 2 more examples. Look at example 4. Page 332, it says, in the kaleidoscope image, AE equals BE. So I need you to find those. It's all mixed up in there. It's all these colors and all these mix-ups, but it says AE equals BE. If AE equals BE, what does that tell you about E? It's a midpoint, which is required for this theorem to apply. Okay, it also says that AD equals DC, meaning D is a midpoint, making DE a mid-segment, making it parallel to CB and half the length of CB, which means its length is the same as CF or BF. Guys are awesome. Okay? It says show that CB is parallel to DE. We're not doing that. We're not doing that proof. So anyway, that was fun to talk about that kaleidoscope, but we're not doing what they want us to do. Move on. Example 5. Now this one takes a little more ingenuity, but not much. It's not going to kill you. So get your eyeballs on that map there that is a triangle. And it says, Pear Street intersects Cherry Street and Peach Street at their midpoints, making Pear Street a mid-segment parallel to Plum and half the length of Plum, making it 0.7, half of 14, right? Are you with me so far? Okay, so remember, Pear Street, they haven't asked us to find that yet, because they're telling us the truths about this, and we're making conclusions. Okay. Your home is at point P. Did y'all find point P? Okay. You leave your home and jog down Cherry Street to Plum Street. How far are you going to go?
1.3 miles. No, 2.6.
Yeah. Somebody write that down. 2.6. From there, you are going to go over Plum Street to Peach Street. How far are you going to go? 1.4. Add that. I mean, don't add it. Just keep track of that. That's so totally you've gone from your home to the corner of Plum and Cherry, and then across Plum to the corner of Peach and Plum, and you're keeping track of how far you went. Are you with me? Mm-hmm. Then from there, you're going to go up Peach Street to Pear. How far are you going to go? 1.1. What's half of 25? 12 and a half, so it's 125. 1.125. Are you with me there? Okay. And so now we have gone over, well, no, wait. Up Peach Street to Pear. So now that was the 1.125. Then we're going to turn and go over Pear Street to Cherry. How far are we going? 0.7. Yeah, we decided that, remember? And then back home up Cherry Street. How far are you going to go? 1.3. 1.3, and you would add all those together to figure out how far your job was.
6.25.
Okay. They say it's 7. 7.125?
No.
They say it's exactly 7.
Why didn't she go up Peach Street instead of cut across here and go up Cherry?
I have no idea. We just have to do what we're told.
She's not thinking.
Nope. Is anybody getting 7 by adding those up, or did we get the wrong?
Oh, no,
did we get the wrong sizes?
that's like an approximation. Number 3 has the answer. Yeah, that's 7.125.
Oh, I see. It says so you jog about 7 miles. I see. I'm sorry. I was looking too far down. Yep. 7.125. Did anybody get that? Yeah, by adding them up. So that wasn't that hard. Using the mid-segment theorem wasn't that hard to apply even to that, right?
Yeah.
So it's not going to be a difficult assignment. It's also not going to be a long one. You should easily finish before lunch, and then you can talk and have fun and whatever. The assignment is, are you ready?
Yeah.
1, 2, 3 to 21 odds. No, you're not quite done. So 1 and 2 and 3 to 21 odd, and that should not take you very long. If you get right after it, you should have plenty of time to do what you want until the bell rings.
There we go.